Welcome to Flourishinmath class. Our topic today is solving simultaneous equation by elimination method. There are 4 steps to follow in order to achieve our goal. The first step, multiply equation by a suitable coefficient if applicable to make 2 equations have the same leading coefficient. Step 2. Subtract or add equations 1 and 2. Step 3. Solve the new equation. Step 4. Substitute your result from step 3 into any of the equations 1 and 2 to obtain the other result. Now let's solve this example. 3x minus y equals 12. 2x plus y equals 18. We need to find the values of x and y that satisfies this equation. Here, step 1, which says we should multiply the equation by a suitable coefficient, is not needed because from equation 1 and 2, we have the coefficient of y to be 1. So we can eliminate y. So we had equation 1 and 2. And so we have 5x equal 30. That is because negative y plus y gives us 0. So we eliminated y to get x. So now divide both sides of this equation 5x equals 30 by 5 to obtain x. We have 5x over 5 equal 30 over 5. 5 divides 5, we have 1, and 30 divides 5, we have 6. So x equals 6. Now we substitute x equals 6, which is equation 3, into either equation 1 or 2. But here I substituted into equation 1. Now we have 3x minus y equal 12, which is our equation 1. So substitute the value of x equals 6. We have 3 brackets 6 minus y equal 12. 3 times 6 is 18 minus y equal 12. This implies that 18 minus 12 equal y. 18 minus 12 is 6 equal y. This implies that y equals 6. So we have x equals 6 and y equals 6. So these are the solutions for the simultaneous equations. We can test to see if the values of x and y are correct. So we test with either equation 1 or 2. So we test with equation 1, we have 2x plus y equal 18. So we substitute the values of x and y, which is 2 bracket 6 plus 6. Let's see if this gives us 18. So we have 12 plus 6, and that is 18. Example 2. Solve 27 equals 8x plus 3y and 6y equal 4x plus 39. We need to find the values of x and y. Solution. Here we need to rearrange this equation such that we have all the variables on one side and the constant on the other side. So we have 8x plus 3y equals 27. But for the second equation, we have it to be 4x minus 6y equal negative 39. So we have 4x minus 6y equal negative 39. Equation 1, equation 2. Here, we'll try to eliminate x. So we want to eliminate 8x and 4x. So what we do is to make equation 2 have 8x. So what do? We multiply equation 1 by 1 and multiply equation 2 by 2. Now equation 1 remains the same, and that is 8x plus 3y equal 27, because we have only multiplied by 1. And equation 2 becomes 8x minus 12y equal negative 78, because we have multiplied each of the variable there by 2. So this becomes our equation for equation 1 and equation 2. So to eliminate x, what do? We subtract. So we subtract equation 2 from 1. So we have 15y equal 105. And how did we arrive at this? We have 3y minus 12y. That becomes 3y plus 12y. And this becomes positive 15y. Also, 27 minus 78 gives us 27 plus 78, and this becomes 105. So now we divide both sides by 15 to obtain y. So y becomes 7. So y equals 7. So we substitute y equals 7 into equation 1, which is 8x plus 3y equals 27. So we have 8x plus 3 bracket 7 equals 27. And this is 8x plus 21 equal 27. 8x equal 27 minus 21 if you collect like terms. So 8x equal 6. To obtain x, divide both sides by 8. So we have x equals 6 over 8. And this can be reduced to the lowest term by dividing by 2. We have 3 over 4. So x equals 3 over 4. So this implies x equals 3 over 4 and y equals 7. So we can test on any of the equation. Here I'm testing on equation 2, which is 4x minus 6y equal negative 39. So we substitute the values of x and y. We have 4 bracket 3 over 4 minus 6 bracket 7 equal, so we divide This becomes 3 minus 42, and 3 minus 42 is negative 39, and so this is correct. Now let's solve this third example. We have 2 bracket f plus g equal 20 and 2 over 3f minus 1 over 4g equal 3. Solution. So we have our equation 1 and equation 2. So divide equation 1 by 2 and multiply equation 2 by 12 to make them linear equations. So we have 2 bracket f plus g equal 20. We divide both sides by 2. Then the equation becomes f plus g equal 10. Then the second one we multiply by 12. So we have 12 multiplied by 2 over 3f minus 12 multiplied by 1 over 4g equal 12 times 3. So we can reduce the terms. And so this becomes a linear equation. It becomes 8f minus 3g equal 36. So the new equations are f plus g equal 10, and that's equation 1, and equation 2 is 8f minus 3g equal 36. Now it's easy for us to solve this because they're now in their linear state. So we want to eliminate g here. So we multiply equation 1 by 3 and multiply equation 2 by 1. So we have 3f plus 3g equal 30, and equation 2 remains the same, 8f minus 3g equal 36. Now we see that it's easy for us to eliminate the 3g's there. And how do we eliminate 3g's? We need to add. When we add 3g plus negative 3g, we have 0. So we add. So add equation 1 and 2. So we have 11f, that's 3 plus 8, that's 11f equal 66. F equal 66 divides 11. This implies that f equals 6. F equals 6 is our equation 3, and we can substitute this in any of the equation. Here I substituted into equation 1, which is f plus g equal 10. So substitute the values of the value of f. We have 6 plus g equal 10, and here g becomes 10 minus 6, and g is 4. Now we have f equals 6 and g equal 4. Now let's test on the initial equation 1. You could test on equation 2 as well. So we have 2 bracket f plus g equal 20. So this becomes 2 bracket 6 plus 4, and this becomes 2 bracket 10. That's 2 times 10, and 2 times 10 is 20. So we have it to be 20, and that's correct. Now I have 4 questions here for you. Please solve them in your notebook. Remember to use the elimination method, and I will see you in my next video.